Hello, welcome back to Alien Space Education. My name is Andy from Space for All Education. I really hope you're enjoying the podcast. And today we're looking at something a little bit different. We're taking a little side step from the planets because we've done loads on them. And I want to expand your knowledge of the solar system, the universe, and so on. So we're going to look at something a little bit different. We're looking at comets, asteroids, and more. So just a little bit more for you. And how these icy streaks across the sky, how they impact us, and what we know about them. So, getting into it. Comets, the icy wanderers. Let's start with comets. These are spectacular objects that make dramatic, dazzling appearances when they venture across the sun. Comets are essentially dirty snowballs, composed of ice and dust and rocky material. They originate from the far reaches of the solar system, possibly the Oort cloud. These orbits can be highly elliptical. That takes them from the far distances from the Oort cloud or the Kuiper belt to the inner solar system and back. Now, when we're saying highly elliptical, it means they go so far out, but then they come back in and they can pass the sun and go back out. That doesn't mean that all comets go past the sun. It doesn't mean we see all comets, because remember, the Oort cloud is a big ball around us, so they could come in from all directions, and just because they go past the sun doesn't mean we always see them. So there's a lot of comets we don't see. So let's look at the structure of comets. What are they made of? Well, just like anything, they have an inner, outer core and so on, but they're labelled a little bit differently. So we have the nucleus. This is a solid core of the comet, made up of ice and rock material that can range in size from a few hundred meters to tens of kilometers across. So we're not tens of kilometers, so we're not talking massively big, but big enough that we can see them. Then we have the coma. As a comet reaches the sun, the heat causes the nucleus to sublimate, releases gas and dust from it that form around the glowing cloud around the nucleus called coma. This can be hundreds of thousands of kilometers in diameter. So this is where they get bigger. They got all this gas and everything that can always leave the tail behind it. And that's where it comes from, the coma. But the nucleus is right in the center, holding it all together. So just like a planet, it's got a central core and it builds up in layers. Well, the coma is the outer layers. Okay, then we have the tail. Comets usually have two tails. The dust tail that is formed from particles pushed away from the coma by the pressure of sunlight, and the ion tail or gas tail that is made up from ionized gas pushed away by solar winds. Now, just because the comet comes in this way and we get that, solar winds could be pushing that way. So it could look like some comets have two tails. If you can see them, they're two tails. But generally, when we see a comet, we only see the one tail. However, if you have a better telescope and things like that, you will see more details. One of the most famous comets we all know and love is Halley's Comet, which has been observed for centuries and makes returns to the inner solar system approximately every 76 years. Its last appearance was 1986 and won't be visible again until 2061. How many of you are going to be around to see that? How many of you were around to see it last time? It is big, it is beautiful, and it's highly fascinating. Other more notable comets is Comet Hale-Bopp. Yeah, I said it, Hale-Bopp, which has made a spectacular appearance in 1997. Its long-lasting and bright appearance allowed for extensive observation and study. So the bigger they are, the better they are. The more we see them, the more we observe the universe and what's out there. Comets can tell us a little bit about what's out there. What's in these gas tails, because obviously as light passes through the tails we can see what chemicals they've got inside them. But generally it's ice rock, but we don't know if that's ice water or ice methane or ice nitrogen. But we're studying to find out. Okay. Comets are valuable to scientists because they are considered to be the primitive bodies that have preserved the early solar system's conditions. Study of these compositions can provide insight into materials such as when the solar system was formed. Because when the solar system was formed, you've got to think rocks of everything was thrown in every direction, everything like that. And they go so far out to as far as the Oort cloud and back. They could be picking up debris from that far back and bring it closer to us to study. So they are little intergalactic travellers that bring us stuff. Asteroids, the rocky remnants. Next, let's turn our attention to asteroids. These rock remnants are from the early solar system, mostly found in the asteroid belt between Mars and Jupiter. Okay, they're leftover building materials from the formation of the solar system, and they come in a variety of shapes and sizes. Now remember, some asteroids in the asteroid belts, especially in the Kuiper belt, we have dwarf planets as well, so there are bigger things as well. Larger asteroids in the asteroid belt is Ceres. Now it's also classified as a dwarf planet, so it's both an asteroid and a dwarf planet, and I didn't cover in dwarf planets for that reason, because it's in both. Ceres has a diameter of about 940 kilometers, roughly 580 miles, and it features a diverse surface with bright spots that are thought to be deposits of sodium carbonate. Now that's unusual. We don't often see that in anywhere except for on Earth, but to find it on an asteroid, do some research yourselves. See where else you can find sodium carbonated on other things, because it is a very interesting one to actually be specific about and that we know. Asteroids are categorized into different types based on their compositions. So this is where things get really, really interesting. Type C are carbonous, which are mostly asteroids which are rich in carbon, and they are dark and contain a lot of clay and silica rock. So we are very dark ones. Silicous asteroid components made of silicate materials and nickel and iron, and they are relatively bright and make up a significant portion of the known asteroid population, mainly because they're brighter we can see them. Type C are darker, so it's harder to see. So there could be more type Cs than there are type S, we just can't see them. And you've got type M. These are metallic asteroid composed of iron and nickel in a higher ratio, and they are less common and tend to be brighter than type C. So you've got type S, which are the really bright ones, type M, and then type C at the bottom. So depending on how bright they shine, depends on how well we see them. Well, that's why there are a lot more out there than we actually know. One of the well-known asteroids, Eros, which is a type S asteroid, which has been visited by NASA near Shoemaker spacecraft, is a mission to provide detailed images about the asteroid's surface. So we're actually going to asteroids and looking at them now. Asteroids can be dangerous to Earth due to the potential impact events. Monitoring and studying asteroids helps scientists assess the potential threats and develop strategies for planetary defenses. Now, we know of two asteroids that have hit Earth. One, the great one that wiped out dinosaurs. The other one that caused a great crater in the, I believe it's Utah desert in America. So we see two asteroids impact craters. There are others around the world. Please don't get me wrong. They're just the two most well-known ones that I know off the top of my head. So by studying them, we can learn about them, but we've got to make sure they don't come near us. Now, we did send a recent mission up that gave a little push to asteroid, and it nudged it just ever so slightly, collected some material and returned it back to Earth, and we've got the scientific data for that. And that showed us that we can also, just because we nudged it, we landed on it, well, we bumped into it, grabbed a load of soil and came off it, we actually moved its trajectory, a tiny little fragment, only a few degrees. But if we can do that, it means we can knock asteroids in the future that may cause potential hazard to life on Earth. So we are on missions, and we are studying ways to protect Earth today. Now let's move on to the little bits. The meteoroids, meteors, and meteorites. All the same thing, but exactly the same. Now, meteoroids, meteors, and meteorites are terms that often get mixed up, but each refer to different stages of space debris that interact with the Earth. Meteoroids. Meteoroids are small fragments of rock or metal from asteroids or comets that travel through space, and they can range in size from a tiny grain to the size of tiny grains of dust to large boulders. So they can be of all different sizes. But while they're in space, they're meteoroids. Okay? Meteors, when the meteoroids enter Earth's atmosphere and they start burning up due to the friction in the air. This creates a streaks of light across the sky known as shooting stars or meteors. Okay? And the meteorites are the fragments of the meteoroids that survive their fiery passage through the atmosphere and land on the surface. They can vary in size from tiny particles to large masses weighing several tons. So meteoroids are in space. Meteors when they hit the atmosphere, and meteorites when they actually land on the ground. So meteoroids, meteors, meteorites. Okay, the T is when they land on the ground, remember. Meteoroids are when they're like asteroids. Easiest way to remember it. The most famous meteorite impact is the tungsten event, which occurred in 1908 in Siberia. This caused an explosion and the meteoroid or comet in the atmosphere, which flattened the large area of forest. So not only can they explode in space and come down, they can explode in the atmosphere, and then they can hit the ground and cause even another explosion. So there are different events that happen. So they are, we do have to watch them very carefully. Another significant meteorite is the Aldebaran meteorite, which fell in Mexico in 1969. It's notable for its age and the valuable scientific information it contained about the early solar system. Studying meteorites can help scientists understand the composition of other celestial bodies and provide clues about the early solar system conditions. Now, why is that? Because just like archaeologists and that, they dig down, they discover old buildings and everything like that inside. Meteorites have ancient little molecules that we need to dig down and discover, and by bringing them to Earth, the solar system saying, here's a little clue about what happened back in the early solar system. It's fun to learn, isn't it? And this is where they come from. So what else is there? We've got interstellar visitors, cosmic wanderers. Occasionally we had objects from beyond our solar system, known as interstellar visitors. These objects that originate from other star systems and pass through our solar system. So where comets, meteorites all come from within our solar system, we do get stuff from outside our solar system. The most famous interstellar visitor, let's see if I can pronounce this, Oumuamua, I apologize if I said that wrong, which was discovered in 2017, is its unusual shape and high velocity suggests that it was not a typical asteroid or comet. Some scientists have speculated about its potential origins and nature, though its exact nature remains a subject of debate and a complete mystery. We can predict where it came from. We can predict its path. But due to known gravity, dark matter, dark energy, tidal forces in the galaxy, not just here in our solar system, they can all impact its path. So how that came to within a range that we can discover it is very, very difficult. And we're still learning to do that, to work out exactly where it came from. Another notable interstellar object is 21 Borisov. That's Boris OV. A comet discovered in 2017 is identified as an interstellar comet due to its hyperbolic trajectory, indicating it came from another solar system. So you've got to think, if a comet comes around about every 100 years, give or take, for 21 Boris, which was discovered in 2017, could mean it could take thousands of years. This comet has been flying around and it's interstellar. So if we're lucky enough and that pass is close enough for us to study it really, really detailed, and maybe some of those small fragments come off and we can look at that, and we can look at the colours, we can learn a little bit about, oh, hang on, that's picked up dust from this. That doesn't come from us. What's in that dust? Oh, this is interesting. Could that be hydrogen, helium, other substances? We don't know. But by studying these, by looking at them, by working out their flight path, we can say, oh, that come close. And maybe it doesn't slingshot around the sun like most comets do. Maybe it just uses it to divert past the sun and then keep going back out the back. We don't know how or why these things happen. We just know they do. But the more we look and the more we discover, the more we learn. Studying these interstellar visitors provide valuable insight into the composition and dynamics of objects from other solar systems. They offer a rare opportunity to study materials from outside our solar neighbourhood. So they are crucially important, but what they pick up and bring with them to us, helps us. So like little trains that come past saying, here's a little gift, we come from outside, have some of this information, and then keep flying on. So nice of them. Even our little galactic neighbours want us to learn more. The Kuiper Belt and the Oort cloud. So you've got to come beyond the Oort cloud to be interstellar. Okay. Beyond the orbits of Neptune lies the Kuiper Belt, regions populated by small icy bodies and dwarf planets, which I've already covered. This region of remnants from the early solar system is believed to contain many objects that could provide clues about the solar system's formation. The Kuiper Belt extends about 30 AU to 50 AU, so it's 20 AU thick from the Sun, and contains a diverse collection of objects, including dwarf planets like Pluto, Haumea, and Makemake. It is also home to many smaller icy bodies and comets and asteroids and more. Further out lies the Oort cloud, a theoretical cloud of icy objects that are thought to surround the solar system at a distance of up to 100 AU. The Oort cloud is considered to be the source of long-period comets that have a slightly higher elliptical orbit that can take thousands of years to complete a single orbit around the Sun. So the Oort cloud may be much farther away, and the comets may take up to 1,000 years, but interstellar objects only pass once. So the further away, the longer it takes for us to see this comet, and the longer we take to project its path, means it could be from this Oort cloud. Study of the Kuiper and Oort clouds help scientists understand the outer reaches of the solar system and provide insight into the early conditions that led to the formation of planets and other celestial bodies. Now you got to think, the solar system is generally flat. That's how we see it on maps and everything like that. And Pluto and the Kuiper Belt's all right at the very back here. But the Oort cloud is a cloud. It goes around in all directions. It's covered us like a balloon. So comets don't always follow that path. Pluto doesn't follow the flat path. It's at an angle. It's slightly higher, which is why it got declassified as a dwarf planet. But it also changes its orbit like a comet. It goes in and out like a comet. But it's very wide. It's got a very large angle. It only comes as close as Neptune. It goes just inside Neptune and then goes wider out again. So it doesn't come as close as comets do. but it's the easiest way to describe the correlation between Pluto, Kuiper belt, and comets. But you got to think the Oort cloud. These comets, they are so far away, 100,000 AU, sorry, and they go round, and they could, like I said, they can come in all different directions, which makes them extremely rare to see, extremely hard to predict. The regular ones we see follow the same path, and they come past us, so we do see them. Okay. The importance of studying these things. Why is it so important? Understanding the diverse array of objects in our solar system provides valuable insight into the formation and evolution of our cosmic neighborhood. Comets, asteroids, and other space debris offer clues about the early solar system, the materials that formed the planets, and the process that shaped the solar system's structure. So it's bringing everything together. By learning these, we can see the pathways we took and what materials we needed. Studying these objects also has practical implications, such as assessing the potential threats of asteroid impacts and develop strategies for planetary defense. Additionally, the exploration of interstellar visitors from outer regions of the solar system help us understand the broader context of our place in the galaxy. So we can understand that these things are further away, they come past us, but it helps us know what's out there and what we can expect. As we continue to explore and study these fascinating objects, we gain a deeper appreciation to the complex and diversity of our solar system and the universe beyond. Because even though we say these are interstellar, and we think they come from within our own galaxy, because they only pass us once, who's to say they didn't come out from further afield, and they could have picked up a lot more material and brought it to us. As we conclude today's journey through this intriguing world of solar system objects, it's clear there is much more to explore beyond our familiar planets. The ice of comets and rocky asteroids, to the distance of the Kuiper belt and the mysterious Oort cloud. Each object continues our understanding of the solar system, history, and its current dynamics. By learning this, we're not only learning about the past, but we're learning more about today, and hopefully we can start predicting the future. I really hope you enjoyed today's episode of Alien Space Education. We look forward to the next one, which will be on, our next one is going to be on, no, wrong sheet. Sorry. It's going to be on nebulas. We're going to start looking at the nebulas. So we're going to look at the gas clouds that are out there. So I really hope you enjoy. I hope you join me for that. And please like, share, leave comments, join up, do whatever you need to do. But the more help you give me, the more I will keep doing this. I love doing this. I love sharing knowledge. I love teaching. So please help me to teach you better. Don't forget to send me questions if you have any. Look forward to hearing from you all soon. Thank you. Take care.